Okay class, let's take a look at this question that you cannot do. It's on page 25 of the 10-year series. It's question 4. Right, so this question is talking about this. The diagram shows a triangle ABC in which angle A is pi over 6 radians. In this case, since we have not learned radian in E-math, right? Let's change the question. Okay, not say change the question, I will change radian into degree. Okay, but the question will still be the same. Pi over 6 radian is equivalent to 30 degree. Okay, so let's change it. We can still do this question even if you don't know what is radian mode. Alright, so let's change it to 30 degree. Angle B is the right angle, M is the midpoint of AB, M is the midpoint of AB, and the length of AC is 8. Okay, the first two sentences give us a lot of information. If M is the midpoint, that means these two lines are the same. Now they say, without using a calculator, doesn't really mean you cannot use a calculator, it just means that they want answer in exact form. Find the value of the integer k, this k, such that angle ACM is here, such that angle ACM is equal to sine inverse this. Oh, so what are they talking about? What do they want? They just want us to find the value of the integer k. But angle ACM is here. Angle ACM encompass this portion. I mean this portion, right? You can see here shows a triangle, but this triangle is not right angle triangle. When you have a triangle that is not a right angle triangle, can you apply Tuakaso? No, right? Can you apply Pythagoras theorem for triangle ACM? No, right? So what will you think of? Okay, if you are thinking of cosine rule and sine rule, then you are right. But in this question, they are talking about sine inverse here. Okay, that means if you work backwards, we are seeing this angle AC, sine angle ACM equals to square root k over 14. Alright, this gives me the hint that I should use sine rule instead of cosine rule. Okay, with this in mind, I can proceed on to do this question. I will keep in mind that I will be using sine rule. But before that, there are other information that I need to find out. Okay, for example, I need to find out what is AM. Because for sine rule, I need sine ACM over AM equals to sine this angle over 8. Am I right to say that? Yeah. But we don't have this angle, right? So, in other words, we cannot use this angle. That means we have to use sine ACM over AM equals to sine 30 over CM. This is possible because I'm able to find CM. So you are seeing what Mr. Liu is thinking. Okay, my thought processes. Can you see? Yeah. So I will be getting this. Okay, but before that, I will need this and this. Once I have these two, I can find this using Pythagoras theorem. Once I have this, I can apply sine rule. Okay, then that's the end of the question. Alright, so let's start showing our working. Okay, actually what I'm doing is actually showing you the steps of Polya. Okay, my thinking processes. So now, first step, I have 8 meters over here. I have 30 degree. I have a big right angle triangle. Definitely Tuakaso. So Tuakaso, I will apply Tuakaso. I have sine 30 degree equals to BC over hypotenuse 8. Alright, so BC will be equals to 8 times sine 30. You can press our calculator. Okay, in fact, if you keep it as pi over 6 radian, you press your calculator in radian mode, it will still give you the same answer here, which is what? You press your calculator, it gives you 4. Okay, make sure it's in degree mode. So BC is 4. Okay, every time I get new information, what did I say? Update 4. So I have 8 meters, I have 4 meters, I can find AB. Right? I can find AB. What formula to use? You can continue to use Torcaso, or you can use Pythagoras theorem. I will use maybe Pythagoras theorem. Okay, seems easier. So AB square plus 4 square equals to 8 square. AB square equals to 8 square minus 4 square. Okay, then what's next? Calculate lah. 8 square minus 4 square, 64 minus 16. I get 48. AB will be equals to square root of 48. This is not good enough because we have learned surds. Okay, how to simplify this? There is a square number in 48, which is 16. Okay, so it's 16 times 3, right? So eventually square root of 16 is 4. 4 square root 3 is a better answer. You realize 4 square root 3 will be a better answer because eventually what they want is I want to see everything in nicely inserts. Okay? So I have AB equals to 4 square root 3. If AB is 4 square root 3, what is MB? Half of AB, right? So half of 4 square root 3 is 2 square root 3. AM also 2 square root 3. 2 square root 3, 2 square root 3, altogether 4 square root 3. So now if I have 2 square root 3, I have 4. Can I find MC? Another time for you to do Pythagoras theorem. Okay, 2 square root 3 and 4. Pythagoras theorem, find MC. Okay, so MC square plus, okay, sorry, my bad, it's not MC square plus, MC square equals to 2 square root 3 whole thing square plus 4 square. This is 4, 3, this is 12. This is 16. Altogether is 28. MC square is 28. MC will be equals to square root 28. Is there a square number within 28? A factor of 28? Oh yes, there is, 4 times 7. So you get 2 square root 7. Okay, so MC is 2 square root 7. Take note, every time I have new information, I write down. MC is 2 square root 7. If this is too fast, please pause the video. MC is 2 square root 7. Okay, I'm ready to go. Because I have one side, two side, one angle, and my reference angle here, I can apply sine rule. Sine this over this length equals to sine 30 over this length. Agree? Can, So I will do it on the next page. Okay, sine rule, sine this angle over 2 square root 3 equals to sine 30 over 2 square root 7. So slowly you notice that I'm working towards this already. Okay? Because the angle ACM is here. The sine is here. Later I'll just bring over the sine to become sine inverse. Alright, so what do I do now? This 2 square root 3 and this sine 30, everything I throw over. ACM equals to Before that, sine 30, what number is sine 30? Sine 30 is actually half over 2 square root 7. Okay, it's not good. It's not right to write a fraction within a fraction. But actually, you can evaluate this. Okay, but try not to write this. The half later, it's better to write 1 over 2 divided by 2, which is 1/4. Okay, but never mind. Since there's a 2 here, I can cancel out. Cancel out. What else can I do? It will be square root 3 over 2 square root 7. Okay, not nice, right? This is not what I want. Look at this. Square root k over 14. Okay, focus, it's square root k over 14. Doesn't look correct. Okay, so let's see. I cannot see cert as the denominator, right? So multiply by square root 7. So I get square root 21 over 2, 7. Square root 7 times square root 7 is 7, right? So I will get square root 21 over 14. Is this what I want? Oh, square root k over 14. Square root 21 over 14. So angle ACM is sine inverse square root 21 over 14, which means that k equals 21. Therefore, k equals 21. End of question. Thank you.